I'm Mr. O, here with another moment at the Children's Museum of Houston. Here's your mission. Here's your mission. Here's your mission. I'm in the Special Elite Crime Resolution and Espionage Team, or Secret Headquarters, helping Director Engstrom hand out a few last-minute missions.
I can't read this.
It's in code, you have to decode it.
Oh.
Some missions may go a little bit better than others, but one of the things I really enjoy about handing out missions is getting to write in code. And one of my favorite ways to code things is with color.
I still can't read this.
You're gonna have to give me a minute. To understand how to make coded messages out of color, first you need to understand how it is we see color. And the best place for that is here, Sights Unseen, sponsored by Oxy and the William Stamps Farish Fund. When we see colors like this, we see it because of light. Light, like we get from most light bulbs in the sun, is what is called white light. White light consists of all the colors of the visible light spectrum: red, orange, yellow, green, blue, indigo, and violet. In fact, if we separate light by using diffraction grating like this, you can see the different colors of light. And it is all those colors of light that allow us to see the colors of things. Pretend that these are all the colors of light found in the white light. This box is the colored object we're trying to see. The white light travels from its source to the object. In reality, this happens very fast, about 186,282 miles per second. When light hits the box, some of the colors get absorbed and others get reflected back to your eye. That reflected light is how you see the color. The combination of the colors of light and their relative strength determines the colors that we actually see. If all the colors get reflected back, we see white. And if none of the colors get reflected back, we see black. But what happens if we change the color of the light that's actually shining on the object? Watch what happens to this image as the color of the light changes. Because colored light is missing some of the colors in white light, the reflected light will also be missing colors. That changes the colors that we see, and changing those colors can create some interesting codes. Let's decode this project. Remember, inventing is fun, but it can also be dangerous, so always have a responsible adult helping you. We're an Invention Convention sponsored by the David and Jean Wiley Foundation to invent some codes. For this, you'll need a flashlight that has different light options. You can find them in some big box stores, hardware stores, and online. You'll also need some paper and some standard colored markers. That's it. Really, the invention comes from how you choose to use the light in combination with the marker colors. To figure this out, first, we need to test our colors. Take each marker and make a mark on the sheet of paper. I like to write out the name since it's hard to tell under colored light. Then, shine a colored light onto the paper. Watch what happens to the different colors on the paper. Try some other colors of light as well. What you're looking for are dramatic changes to the marker colors when you shine the light. Specifically, you want to look for colors that either get very dark or very light under the different colored lights. Let's see what happens with these colors under red light. See how the red, orange, yellow, and pink fade? They all contain red, and so reflect back all the red light, making them mostly disappear under the red light. But see how the green and blue turn dark? Blue and green have no red, so they absorb all the red color, reflecting back almost none. When most of the light is absorbed and little is reflected, we see black. So these are the colors I want to use. I want to use the red, orange, yellow, and pink as distractors because they almost disappear under the red light. Then I want to use the blue and green to write the actual code out because they get very dark under the red light. How you want to use the color to invent code is up to you. For example, in this case, I have written my message and several other words in different colors. Seems a little random until I turn on the light highlighting the words in the message. For this one, I made each letter a different color. Altogether, it's nonsense, but with the red light, you can see the correct letters for the hidden message. Now it's up to you to invent your own code. What colors in combination with light will you use? Maybe even you can combine different codes together, like switching out letters for numbers or writing them in mirror, or switching out the letters for numbers and writing those in mirror. Well, no matter what code you choose, the most important part of having a secret code is, of course, keeping it secret. This has been another Oh Wow moment from Children's Museum Houston. We hope your mind can come out to play.